Alright, welcome to day 1 of IB Physics 2. And right off the bat, we're going to start off with an question that's going to get you thinking, but it's one that you should be able to solve based on what you know about static electricity and charge and conservation of energy, which you should have learned about in IB Physics 1. So the question 1 states that two separated identical conducting spheres are charged with 4 microcoulombs and negative 12 microcoulombs respectively. Now, the spheres are allowed to touch and then are separated again. Determine the charge on each sphere. Now, I gave you a hint here, and I even included a diagram to be nice. You're welcome. So the net charge must be conserved. An object naturally wants to be at equilibrium. That is basically the answer to this problem. The hint is the answer to this problem. So, if I tell you that the net charge must be conserved, what should your first move be? Probably to find the net charge. So let's go ahead and go over the solution here. Alright, because of conservation of charge, we know that the net charge must be conserved. So the net charge is simply adding the charges. So I have one sphere with positive 4 microcoulombs and another sphere with negative 12 microcoulombs. So 4 plus negative 12 gives you a net charge of negative 8 microcoulombs. And we know that objects naturally prefer to be at equilibrium at all energy. We'll talk about this more in thermodynamics. But you see with air pressure, right? Air pressure, wind is just air pressure equaling out. We know that energy goes from hot to cold objects until they reach the same temperature. Same with charge, right? Things naturally want to be at the same charge, which is why we have lightning or static electricity. You build up charge and then you touch something that has less charge, and so it equals out. So if net charge is negative 8 microcoulombs, well, I know that each sphere must have the same charge because they're identical conducting spheres. And so I'm going to go ahead and say each sphere has negative 4, negative 4. Alright, this is an easy IB question on the exam. It's one that is probably going to be on the exam. I don't think that never been an IB paper exam with this kind of question has not been on the exam. And it's an easy one to get. Alright, so step 1 is to find net charge, and you have two spheres, so net charge between them. So you get negative 4 plus negative 4 is negative 8. The total charge of the system is still conserved. Do not go, oh, this is negative 8. Excuse me here. That this is negative 8, therefore each sphere has negative 8. Well, if you have negative 8 on each sphere, the total charge is going to be negative 16. And that's where did the extra 8 microcoulombs of charge come from, right? It's not conserved. So remember, the total system has to be conserved. So if you have a total net charge of a system is negative 8, and each sphere has the same charge, then it has to be negative 4 on each sphere. This is an easy IB physics question, and if you miss this on the IB exam, I'm going to scream, alright? Because it's so easy. Just think your way through it. Awesome? Alright, so that's the solution to this one. Let's go ahead and continue on for today.